Hello students, once again I welcome all the standard 10 students on this online classes. So, last class we have discussed about equilibrium of bodies, that means what is equilibrium and types of equilibrium and the conditions for equilibrium and some examples related to static and dynamic equilibriums also we have discussed. Okay. And today we will be going to discuss about the principle of moments, yes, and different type of couples, examples, these all things. Okay, I said that one, that principle of moment also we have discussed, yes, that is sum of clockwise moments is equal to sum of anti-clockwise moments. We have discussed that one. Related to that one also we have discussed previously some examples which is given in your book, yes. So I said that verification of the principle of moments we will do that one practically while you will be coming to school, yes, but theoretically also you must be clear about that. Okay, so let's start this one. I am going to explain that one, how to perform that experiment. Okay, so let's start. Verification of the principle of moment. You all have seen that meter rule. So take a meter rule and drill a small hole on it on the mark 50 centimeter but slightly offset from the center. It is not exactly at 50 centimeter mark. Here you can see from the figure also a small hole is present just exactly right side of that 50 centimeter mark. Yes. Then pivot the rule on a knitting needle so that it balances horizontally. Then what we have to do? We have to balance that meter scale or meter rule horizontally. If one side of the rule happens to be slightly heavier, it will tilt. Yes, obviously this will happen only. Yes, this can be corrected by means of a U-shaped rider made of a thick copper wire. So we can adjust that one, and we have to do, what we have to do? We have to set up that meter rule in horizontal position. It must be balanced. Okay, then hang unequal masses, that is m1 and m2, on either side of the meter rule and at distances d1 and d2 from the pivot, and adjust until the rule once more comes to rest horizontally. So two different masses m1 and m2 we must have to take, yes, and from the pivot it must be a distance, there must be a distance of d1 and d2. Okay, and we have to balance. Yes, unequal masses, not equal. Here m1 is not equal to m2. Okay, the weights w1 and w2 are now exerting equal and opposite moments about the pivot. Obviously w1 is the weight of mass m1 and w2 is the weight of mass m2. Yes, so obviously w1 is acting vertically downward and w2 is also acting vertically downward, but here we can see that one must be clockwise, another one must be anti-clockwise. Yes, w1 is anti-clockwise here and w2 is clockwise here. Okay, so when it is balanced, yes, sum of the clockwise moment is equal to sum of the anti-clockwise moment only, then only it is possible, otherwise it is not possible also. Okay, so the weight w1 tends to turn the rule anti-clockwise while the weight w2 tends to turn the rule clockwise. Total clockwise moment, how can we calculate that one? Formula is there, w2 into d2. Total anti-clockwise moment, w1 into d1. In the equilibrium position, it is found that w1 d1 is equal to w2 d2, otherwise it will be not balanced. Yes. In the foregoing discussion, w1 and w2 produce moments acting in an anti-clockwise direction and clockwise direction respectively. If however there are more than two forces acting on the meter rule, the sum of the anti-clockwise moments is equal to the sum of the clockwise moment. This can be illustrated by arrangement shown in figure 1.14. Another figure is also there. Four weights also we can balance. Both side of the pivots, two weights we can take and balance it also. Okay, in that case how can we calculate that one? Yes, in equilibrium positions, let us see that. So this can be illustrated by arrangement shown in figure 1.14. Four weights are attached to the meter rule and their distances from F that is fulcrum, are adjusted until the meter rule balances. The perpendicular distances of the forces from the fulcrum are then measured. We can know that one. Yes, here you can see that one, D1, D2, D3, D4 are there. So, how can we calculate? Left hand side, whatever the weights are present, that is W1, W2 are present at the left hand side. Yes, and that one will produce anti-clockwise moment, but W3 and W4 are present at the right hand side, and that one will produce clockwise moment. So, sum of the anti-clockwise moment is equal to sum of the clockwise moment only. If it is balanced at that time only, we can say that one. Yes, so that's why it is written here, W1 D1 plus W2 D2 is equal to W3 D3 plus W4 D4. Okay, I hope you have understood. Okay, this one we will perform experiment, okay, in your school also. Parallel forces and couple. Parallel forces which act in the same direction and called like forces, and it is always possible to find them resultant or the single force which exactly replace them. The same usually applies in the case of parallel forces which are unlike or act in opposite direction. There is however one special case in which a single resultant cannot be found, namely where the forces can be shown to be equivalent to two equal and opposite parallel forces. So, here you can see that one, parallel forces and couple. Okay, parallel forces means both the two forces will be parallel to one another. It may be same, it may not be same. Okay, but their directions are different. Yes, here you can see that one, an arrangement of two equal and opposite parallel forces acting along parallel lines at different points is called a couple. So, two parallel forces means same forces, same amount of forces, like forces, but acting oppositely. At the same time, both are parallel to one another. And when it is called couple, an arrangement of two equal and opposite parallel forces acting along parallel lines at different points is called a couple. A couple can be balanced by an equal and opposite couple only. So, here you can see that one, the moment of the couple is equal to the product of one of the forces and the perpendicular distance between them. How can we calculate that product couple, moment of the couple? Yes, it is the product of one of the forces and the perpendicular distance between them. Here the perpendicular distance between F and F, that is between A and B, is D, and one of the forces we have to take, that is F. So, the perpendicular distance between the equal and opposite forces acting on a rigid body such that it turns about a fixed point or fulcrum is called the arm of couple. Yes, so moment of force F at the end A is equal to F into OA, obviously F into D formula will be there. Yes, moment of force F at end B is equal to F into OB only. Yes, so total moment of couple F into OA plus F into OB. So, F can be taken as common, F into OA plus OB. What we are getting, OA plus OB is, that means exactly AB only. Yes, so F into AB. AB is how much we have taken, D. So, what we have derived here, force into distance between that two parallel forces. The moment of couple is equal to the product of either force and perpendicular distance between line of action of both the forces. The moment of couple is independent of the position of point O. Okay, it does not depend upon the positions of O. Yes, that A may be shifted to the right hand side also, B may be shifted to the left hand side also. Anywhere it can be applied. Okay. So, the moment of couple is independent of the position of point O about which the moment is calculated. If the couple has a tendency to rotate the body in an anti-clockwise direction, its moment is taken as positive, and if the tendency of rotation is clockwise, the moment is taken as negative. Okay. Units of moment of couple. What will be the unit? In CGS system, the moment of couple is measured in dyne centimeter and gram for centimeter. In SI system, Newton meter or kilogram force meter. So some examples are also given of couple action. The rotation of a body is due to couple. Any body, if it is rotating, if we are trying to rotate that one, because of the couple action only it is rotating. For example, a pair of equal and opposite forces applied to a steering wheel of a car constitutes a couple, which produces the turning effect. Similarly, the turning of a water tap, tightening of the cap of an ink pot, turning of key in a lock, winding or unwinding of a clock with a key, pedaling of a bicycle and opening of a wood screw are other examples of a couple. Yes, both the side same but opposite in nature, opposite in directions, but same amount of force will be acting, so that rotational motions can be occur. Okay, I hope you all have understood this much. Okay, thank you.